Australia is spending $31 billion to build an insane 1,600-kilometre railway between Melbourne and Brisbane. But why are they spending such a large amount of money on it, and what is the major problem it faces? Stick around, as today we'll dive extremely deep into the Inland Rail mega project. The Australian economy relies heavily on freight transport. Whether it's fresh produce from regional farms, coal for export, or goods destined for urban centres, the country's logistics network is its lifeblood. Yet, this network faces major challenges. The current freight system, dominated by road transport, struggles to keep up with growing demand. Roads are congested, emissions are rising, and trucks are expensive to operate over long distances. This inefficiency increases costs for businesses and consumers alike. Rail transport is 4 times more fuel efficient than road. One freight train can replace 110 trucks, easing road congestion and lowering accident risks. The current freight sector contributes 39 million tonnes of CO2 annually. A shift from road to rail could cut emissions by as much as 75%. With global pressure mounting to address climate change, finding sustainable freight solutions isn't optional, it's essential. Beyond logistics and the environment, there's the issue of regional growth. Rural areas often feel left behind in terms of development. The Inland Rail offers a lifeline, connecting regional centres to major cities, opening up opportunities for trade and boosting local economies. On top of that, with the population in Australia projected to reach 40 million by 2050, freight demand will only grow, making this project even more critical. The origin of Inland Rail dates back to the late 19th and early 20th centuries, with numerous proposals aimed at improving connectivity between East Coast cities in Australia. Prime Minister Andrew Fisher presented this idea in 1915 to link Port Augusta to Brisbane via railway. Ken Thomas in 1979 envisioned a freight route connecting Brisbane to Melbourne via key regional hubs. These plans, however, faced financial and logistical challenges, delaying their realisation. In 1995, Queensland Rail detailed a $1.3 billion proposal for an inland railway corridor, aiming to cut travel time and reduce operating costs significantly. Subsequent studies, including the Bureau of Transport and Communications Economics report in 1996, highlighted the economic benefits of an inland route. This included reducing the operating costs for freight and alleviating congestion on existing rail lines. Despite the potential, these proposals remained on the drawing board due to funding and prioritization issues. Momentum for the Inland Rail grew in the early 2000s, with feasibility studies and route evaluations commissioned by successive federal governments. By 2008, the Australian Rail Track Corporation was allocated funds to develop a route alignment. In 2017, the federal budget allocated $8.4 billion to Inland Rail, solidifying its status as a national priority project. The revised route was designed to enable faster freight movement, reduced costs, and greater reliability for operators. Inland Rail is a 1,600-kilometre freight rail line, now under construction. It will connect Melbourne and Brisbane via regional Victoria, New South Wales, and Queensland. The route was strategically designed to avoid congestion in major metropolitan areas while maximising connectivity to existing rail networks. This project is expected to boost regional economies by improving access to markets, creating jobs, and encouraging investment along the route. Construction is divided into 13 individual projects, each with unique challenges and opportunities. Some segments involve upgrading existing railways, while others require entirely new tracks. This mega project spans 3 states, starting from Beveridge in Victoria and terminating at Kagaru in Queensland near Brisbane. Its alignment was carefully chosen to maximise efficiency while minimising environmental and community impacts. The route integrates 600 kilometres of new tracks with 1,000 kilometers of upgraded or modified existing tracks. This creates a seamless connection between Melbourne and Brisbane. In Victoria, the Inland Rail follows the Northeast Railway line with key upgrades to bridges, platforms, and infrastructure to accommodate double-stack trains. In New South Wales, it includes a mix of new tracks and upgrades, with the Narromine to Narrabri section. It features a 300-kilometre stretch of entirely new alignment, the longest segment of the project. In Queensland, the route utilises dual-gauge tracks to connect with both standard and narrow-gauge networks. This ensures compatibility with regional rail systems. Tunnels are a critical component of the Queensland section. These include the Toowoomba Range Tunnel, Teviot Range Tunnel, and Little Liverpool Range Tunnel. They are all set to replace outdated infrastructure, creating faster and more efficient routes through challenging terrain. The route avoids steep grades, sharp curves, and bottlenecks that slow down trains. The goal is to enable double-stacked freight trains up to 1.8 kilometers long to travel at speeds of up to 115 kilometers per hour. This translates to faster, cheaper, and more reliable freight transport. Inland Rail will use crossing loops at strategic locations throughout its network to ensure smooth train operations. These loops are critical for allowing the up to 1.8 kilometer long freight trains to pass one another, helping to reduce delays and improve operational efficiency. Crossing loops will be strategically placed at key locations along the Inland Rail corridor, particularly in areas where train traffic is heaviest. Several factors influence their placement, including train frequency, operational needs, and the terrain. Now, Inland Rail will easily handle longer trains, prevent bottlenecks, and maintain a high level of service for its freight operations. One of the most remarkable aspects of the plan is its focus on sustainability. By reducing reliance on road transport, Inland Rail is expected to slash millions of tons of carbon emissions over its lifetime. The project also includes environmental offsets like reforestation and wildlife corridors to minimize its ecological impact. One of the standout features of Inland Rail is its ability to deliver freight faster and more reliably. By slashing transit times between Melbourne and Brisbane from 33 hours to less than 24 hours, the rail line offers a compelling alternative to road freight. This efficiency is complemented by the capacity of the double-stack trains, which can carry the equivalent of 110 B-double trucks. These 1,800-meter-long freight trains, capable of traveling at speeds up to 115 kilometers per hour, will handle significantly higher volumes of freight. This will alleviate pressure on the highways in Australia and make supply chains more resilient. How do trains pass each other? Crossing loops and turnouts are essential for managing the flow of trains on single-track railways like Inland Rail. They allow trains to pass each other so that multiple trains can operate on a single-track railway safely and efficiently. The project also brings critical environmental benefits. Rail freight is 16 times more fuel efficient than road transport. Resultantly, Inland Rail will significantly lower carbon emissions in the national freight industry. Reducing reliance on trucks not only cuts greenhouse gases, but also alleviates road congestion and enhances safety. Regional towns, often burdened by heavy truck traffic, will see reduced volumes of large vehicles, easing wear and tear on local infrastructure and improving overall quality of life. Economic growth is another cornerstone of Inland Rail. The project has already injected billions into regional economies, with over $3.7 billion awarded in contracts. $424 million has been spent in regional areas since construction began. Job creation is a major driver, with more than 6,200 people employed between 2018 and 2024. Moreover, 743 businesses, including 36 First Nations businesses, have contributed to the project, with local businesses earning nearly $500 million so far. These numbers reflect the widespread and long-term benefits Inland Rail is delivering to communities across Australia. The rail line also serves to future-proof freight networks in Australia. With an increasing population and climate change posing challenges such as adverse weather events, the need for a resilient and reliable freight system is more pressing than ever. Inland Rail provides an alternative route to the existing coastal line, enhancing the capacity of the overall network and ensuring that supply chains remain operational during disruptions. By improving connections to Adelaide and Perth through the Northwest Connection at Parkes, the project further solidifies its role as a backbone for national logistics. Inland Rail addresses the critical need to link regional producers with markets, offering better access to national and global trade opportunities. It carries essential goods, including food, white goods, medical supplies, and industrial equipment, strengthening supply chains across industries. By reducing freight costs and improving delivery reliability, Inland Rail ensures Australian businesses remain competitive in an increasingly globalised market. Technology plays a vital role in the Inland Rail. Advanced signalling systems ensure safety and maximise efficiency, while automated tracking systems provide real-time updates on freight movement. These systems help operators make informed decisions, reducing delays and enhancing the overall reliability of the network. The railway is also future-proofed with provisions for further technological upgrades, ensuring it remains a state-of-the-art asset for decades to come. Sustainability is another hallmark of the Inland Rail. By shifting freight from road to rail, the project is expected to reduce greenhouse gas emissions by up to 750,000 tonnes annually. This reduction is significant in the context of Australia's climate commitments and represents a meaningful step toward a greener future. The railway also incorporates environmentally conscious measures such as wildlife crossings and reforestation efforts to minimise its ecological impact. This mega project promises faster, safer, and more efficient freight transport, a greener and more sustainable logistics network, and significant economic opportunities for businesses and communities. Inland Rail is a game changer, transforming how Australia moves goods while ensuring the nation remains competitive and connected in the decades to come. The Inland Rail is a monumental investment with a budget of $31 billion. Such a large-scale project requires meticulous planning and allocation of resources to ensure its success. The bulk of the budget is dedicated to construction, which involves building new tracks, upgrading existing ones, and constructing complex infrastructure like tunnels and bridges. These components are vital for ensuring the railway meets modern safety and efficiency standards. A significant portion of the budget is also allocated to technology. The Inland Rail incorporates state-of-the-art signalling and automation systems, which require substantial investment. These systems are critical for ensuring the railway operates safely and efficiently, minimizing delays and maximizing throughput. Additionally, the budget includes costs for integrating the railway with existing networks and ports, a task that involves significant engineering and logistical challenges. Land acquisition is another major expense. The 1,600-kilometre route passes through diverse landscapes, requiring negotiations and compensation for landowners. This process, while costly, is essential for ensuring the smooth progression of the project and avoiding disputes that could delay construction. The budget also accounts for contingencies. Large infrastructure projects often face unforeseen challenges, such as rising material costs or environmental concerns. By including a buffer for these eventualities, the project aims to stay on track financially, even in the face of unexpected obstacles. Constructed by Inland Rail, a subsidiary of the Australian Rail Track Corporation, on behalf of the Australian government, the project represents a strategic investment in the national logistics future. Funding for the Inland Rail comes primarily from the federal government, with additional contributions from state governments and private investors. This public-private partnership model spreads the financial burden while ensuring accountability. While the price tag is undoubtedly high, the long-term benefits far outweigh the initial investment. The railway is expected to generate significant economic returns through reduced freight costs, job creation, and increased trade competitiveness. Construction of the Inland Rail began in earnest in 2018, with the Parkes to Narromine segment marking the first phase. Completed in 2020, this section demonstrated the potential of the project, employing over 1,800 people and integrating advanced construction techniques. Subsequent stages have faced challenges, including land acquisition disputes, environmental concerns, and rising material costs. Environmental considerations have been a recurring issue. Sections of the route, such as the Narromine to Narrabri alignment through the Pilliga forests, have drawn opposition from Aboriginal land councils and environmental groups. Concerns over hydrology, particularly the Yallarbon to Gowrie section crossing the Condamine River floodplain, prompted reviews and legal challenges. Despite these setbacks, Inland Rail Pty Ltd has worked to address stakeholder concerns. They conducted extensive consultations and modified plans to mitigate environmental impacts. In October 2022, the Australian government commissioned an independent review of the Inland Rail, led by Kerry Schott AO, following reports of cost overruns and delays. Released in April 2023, the review reaffirmed the importance of inland rail for the growing freight needs in Australia, but it identified the governance and management deficiencies. Recommendations included shortening the route to extend from Beveridge, Victoria, to Ebenezer, Queensland. It also included prioritising upgrades to existing tracks to minimise environmental and community disruptions. The government accepted 19 of the recommendations in the review, including the phased completion of the project. The Beveridge to Parkes section is now set for prioritisation, with a target completion date of 2027. Inland Rail, operational as a subsidiary company from early 2024, has taken over construction responsibilities to improve focus and accountability. Building the Inland Rail is a gigantic engineering project requiring a combination of advanced technology, skilled labour, and heavy machinery. The construction process is divided into 13 segments, each with unique challenges. Some segments involve upgrading existing railways, while others require entirely new tracks to be laid across challenging terrains. One of the most demanding aspects of construction is earthworks. Large-scale excavation and levelling are required to create a stable foundation for the tracks. This involves the use of heavy machinery like bulldozers, graders, and excavators. In some areas, thousands of tons of soil are moved to achieve the desired gradient and alignment. Advanced surveying techniques, including drone mapping, ensure precision during this phase. Bridges and tunnels are another critical component of the project. With over 100 bridges and several tunnels along the route, these structures are vital for ensuring the continuity of the railway across natural barriers. The Toowoomba Range Crossing, for instance, features one of the largest tunnels ever built in Australia. Tunnel boring machines are used to carve through solid rock, while high-strength concrete and steel ensure the structures can withstand heavy loads and seismic activity. Track laying is a highly automated process, all due to specialized machinery like track laying trains. These machines streamline the placement of sleepers and rails, dramatically speeding up construction while maintaining high levels of accuracy. Once the tracks are in place, ballast, crushed stone that provides stability, is distributed and compacted using ballast regulators. The construction process also involves significant environmental considerations. Measures like sediment control prevent water pollution during construction, while wildlife corridors ensure that animals can safely cross the railway. Additionally, the project includes reforestation initiatives and other offsets to minimize its ecological footprint. Inland Rail and its construction partner, McConnell Dowell, have installed 18 3D printed nesting boxes on the Seymour Avenel RD construction site in Victoria. The new artificial hollows boost habitat opportunities for local wildlife that may have been disrupted by the nearby construction activity. It aims to provide safety and shelter for numerous native birds and mammals, including crimson rosellas, turquoise parrots, sugar gliders, and the brush-tailed phascogal. Computer-aided design and manufacturing techniques are used to mimic natural hollows, potentially improving the performance of attracting and protecting wildlife. The artificial hollows are made from 3D printed wood, mycelium, or hempcrete. Cameras are set up to monitor the sites and have already filmed wildlife moving into the new homes. Skilled labor is essential for the Inland Rail. Thousands of workers, including engineers, machine operators, and construction crews, are employed across multiple sites. Inland Rail Skills Academy graduates have used their newly acquired skills to find employment with Inland Rail contractors. Training programs have been established to upskill workers and prepare them for the specialized demands of railway construction. Safety remains a top priority throughout the construction process. Rigorous safety protocols are implemented to protect workers and communities near construction sites. Regular inspections and the use of advanced safety equipment minimize risks, ensuring the project complies with the highest standards of occupational health and safety. Additionally, community engagement initiatives help address concerns and ensure transparency in the development of the project. Technology plays a crucial role in every stage of construction. Advanced modeling software helps engineers design and simulate the railway before any ground is broken. This reduces the risk of errors and ensures the project proceeds smoothly. Automated monitoring systems track progress in real time, allowing for immediate adjustments as needed. The machinery used in the Inland Rail is among the most advanced in the world. From tunnel boring machines to high-capacity cranes, the equipment is designed to handle the immense scale and complexity of this mega project. Mobile concrete batching plants are deployed to ensure a steady supply of materials. Similarly, automated welding machines join rails with precision and durability. Nearly 20% of the railway is completed, but its ultimate cost and completion date remain uncertain. CEO Nick Miller stated they aim to complete the Beveridge to Park section by 2027, pending ongoing approvals. Approvals for land acquisitions in New South Wales and environmental permits in Queensland are causing significant delays. These Queensland environmental approvals are especially complex and could take several years to finalise. State and federal approvals for the Narromine to Narrabri section have been secured, demonstrating some progress in construction. Land acquisitions between Narromine and Ebenezer are the focus to provide cost and schedule clarity to the government. The federal government has allocated $14.5 billion, but the total cost is now projected to exceed $31 billion. An independent review by Kerry Schott identified governance issues and inefficiencies contributing to rising costs and delays. Schott emphasised the importance of Inland Rail to Australia, but recommended better management practices to address the project's challenges. The rail networks in Australia face broader challenges, including outdated infrastructure and inconsistent regulatory frameworks across states. CEO Paul Scurrah of Pacific National criticised policies that hinder innovation and limit rail freight's competitiveness with road transport. He called for increased investment to eliminate bottlenecks and improve the nation's supply chain infrastructure. Andrew Harding, CEO of Aurizon, highlighted challenges with the fragmented standards of rail, including 29 networks, 3 gauges, and 11 signalling systems. These inconsistencies undermine productivity, safety, and the ability of rail to compete effectively with trucks. The Australasian Railway Association is advocating for national regulations to improve reliability and frequency in rail freight services. According to Georgia Nichols, Freight General Manager, ARA, reliability and speed are bigger issues than cost for businesses. Currently, rail freight accounts for less than 2% of Melbourne-Sydney goods and less than 5% of Sydney-Brisbane. Even between Melbourne and Brisbane, only 30% of goods are moved by rail, despite the potential of inland rail to improve this. Extreme weather events have further exposed vulnerabilities in the rail networks of Australia, disrupting freight and supply chains. Cyclones and flooding this year caused major delays in Queensland and Western Australia, affecting rail freight operations. ARTC CEO Wayne Johnson acknowledged the need for infrastructure capable of withstanding increasingly severe climate impacts. The ARTC completed a hydrology study to improve network resilience and ensure faster recovery from extreme weather disruptions. The Inland Rail project has recently achieved significant milestones, particularly in New South Wales. On November 5th, 2024, the Australian government granted final approval for the construction of a 39-kilometre rail link between Illabo and Stockton Bengal. This new alignment is designed to bypass the towns of Cootamundra and Bethungra, thereby avoiding the steep gradients of the Bethungra spiral on the main South Line. This development is expected to enhance the efficiency of freight transport in the region. In the town of Parkes, NSWs, the Inland Rail Board, led by CEO Nick Miller, visited the Parkes Special Activation Precinct. Following the visit, Mr. Miller declared Parkes as the flagship city of the Inland Rail project. Parkes is strategically positioned at the junction of the two major rail spines in Australia. This makes it a crucial connector on the Melbourne to Brisbane Inland Rail line, as well as the Trans-Australian Railway linking Sydney to Perth. This unique positioning underscores Parkes' importance in the national rail network. Community engagement remains a priority for the project. Inland Rail has unveiled updated designs for the Euroa railway station surroundings in Victoria and is actively seeking feedback from local residents. The new designs feature modern station facilities, landscaped gardens, and improved connectivity for pedestrians and cyclists. Construction is set to begin next year, with the input from the community playing a vital role in finalising the plans. Despite these advancements, the project faces challenges, particularly in Queensland. Progress has slowed, and there are concerns that the rail line may not extend beyond the Nessas-Dawala's Queensland border to reach Toowoomba as initially planned. This has raised questions about the project's scope and timeline in the state. Financial considerations have also come to the forefront. An independent review revealed a cost increase to $31 billion, prompting the government to amend its plans. The current focus is on completing the section from Melbourne to Central Western Nessas, with the extension to Brisbane deferred. This phased approach aims to manage resources effectively while addressing the most critical segments of the project first. In response to these challenges, innovative proposals have emerged. A consortium has suggested constructing a 60-kilometre tunnel connecting Gowrie near Toowoomba to an intermodal terminal at Ebenezer near Ipswich. This $7.2 billion project would utilise battery-powered automated shuttles to transport freight directly to the Port of Brisbane. This aims to alleviate congestion and enhance economic viability. The Inland Rail project is making notable progress, especially in Nessas-Dawes, with key approvals and community engagement initiatives. However, it continues to navigate financial constraints and logistical challenges, particularly concerning its extension into Queensland. Innovative solutions and strategic planning are essential as the project advances toward its goal of revolutionising freight transport across Eastern Australia. Over its first 50 years, it is expected to inject $18 billion into the Australian economy. This includes benefits such as reduced freight costs, job creation, and increased economic activity in regional areas. By addressing inefficiencies in the freight system, the railway positions Australia as a leader in sustainable and efficient logistics.